Hi guys, welcome to the Advent YouTube channel, and this is Nixon. Today we are going to solve a problem. This problem is from GeeksforGeeks. It's a medium complexity problem. Swap kth node from ends. Given a single linked list of size n and an integer k, you need to swap kth node from the beginning and kth node from the end of the linked list. Swap the nodes through the links. Do not change the content of the nodes. And let me explain the problem shortly. Initially, we'll be given a linked list and the number of linked lists and the k value. We have to swap the k values from the beginning and the k values from the end. So here 1, 2, 3, 4 is a node. Usually here we have 4 nodes and we have to swap the first value from the beginning and first value from the end. The first value from the beginning is 1 and the first value from the end is 4. We have to swap that. If we swap it, we'll be getting the answer as 4, 2, 3, like this. And in this problem, we have several corner cases which has to be monitored. So let me explain. Initially, let me explain the corner cases of this problem. So first of all, we have to check whether the head value not equal to null or head value is single or not. And first we have to take whether the head value is null or whether the next of the head value is null. And then we have to check that whether the k value is greater than none. If we in this example, the total number of nodes is 5 and the index value is 7. The k value is not available here, so we have to directly return the head. So we have to check the k value is greater than none or not, and then we have to check whether the k value is equal to 1. If we had the k value as 1, we have to change the head values. So we have to take this as a corner case, k equal to 1, and then we have to check another cases here. Let me explain with an example. So I'll be having a value the linked list as this, and I'll be having my num value as 4, and then I'll be having my k value equal to 1. Okay, so if I swap 1 and 4, I'll be getting the answer as 4, 2, 3, 1. And another case, if the k value is 4, we'll be getting the same values here. So please check this. If the k value is 4, for sure we'll be getting this values. So, and here we have to check that k value equal to null or not. And then fourth one is we have to check whether the first node is the neighbor. The next of the first node is the neighbor values. In this example, let me explain with this example. If the k value is 2 for the example, we'll be getting that 1, 3, 2, 4. And if we get these values, the neighbor values, we'll be getting the neighbor nodes here. So we have to take this as a corner cases, neighbor nodes. That's it, guys. And we have to get rid of all these 4 corner cases. And now let's start solving the problem shortly. I'm going to create and first num feature as k, and I'm going to create second num equals to minus k minus 1. So by using this, we will be getting the second index. So 1 and 4 is the index. The first index is 1 and the last index is 4. So we'll be getting the first num and the second. And then I'm going to create node for first value, assigning as head, node for second last value, assigning as head, and first previous equal to head and the last previous equal to head and the first next to head and the last next equal to head. So this was the thing, and then I'm creating a count integer to count the indexes, and then I'm creating a temporary node. I'm creating a temporary node here. Now I'm going to apply every corner cases here. So yeah, let me play. And another corner cases here was whether the num equals to 2. So this, it's also a corner cases we have to check. Yeah, let me explain. If head equal to null or head dot next equal to null or key value is greater than null. And then we have to check here whether the number is equal to 2. So we just checked it, and then we have to check here whether if k equal to 1 or k equals to no. Else but. So these are the corner cases we just applied here. Yeah guys, and then here we have to check whether the first next equals to last and then else part. So we just created a structure of the problem structure. Yeah guys, we just structured the problem. We have to move it here. We have to return it here, and then we have to, as earlier we talked that we have to the solution for the both corner cases same. So we have to bridge. We are going to bridge the solution of both the corner cases. So I'm going to bridge key equal to null. I'm going to swap the first values. And the another way also here, the solution for these both the solution is same here. So we have to bridge these two solutions too. Here I'm going to check whether first num equal to so here we are checking whether the two nodes are neighboring nodes or not. And also we are going to check that whether the first is greater than the second one. We have to swap here. Yeah guys, now we are moving into the solution. And first we are going to check whether the num value is 2 or not. and if the num value is 2, we have to just we're going to swap it, and the procedure is the next of the second value, last value is the first, and the next of the first value is null. So this was the procedure, and the last dot next equal to first, and the first dot next equal to null. We have to assign the value for the last equal to head dot next, and then we have to change the value of head equal to last, and then we have to return the head here, and then we are going to another cases. We are going to run a loop here from temp not equal to null, and then we are going to increment the count, and we are going to traverse a linked list, and if count equal to second num, we are getting the previous value, last previous equal to temporary value. Here first equal to head, and the first previous value is always null, and the second value equal to last value equal to last previous dot next, last next equal to last dot next, and the first next equal to first dot next. And then now we are going to hook up. So we'll be getting this is an example 1, 2, 3, 4, and the k value equal to 1. We're just going to link it. The k value equal to 1, the head of the value should be changed from k equal to 1. Okay, yeah, and the head of the value should be changed from 1 to 4. So with that, last value dot next equal to first next, and the last dot next value, the next value of the last is, so by doing this I am declaring that 4, 3 and 2, and here last previous dot next equal to first, so I am declaring it, and the first dot next is always null here. Then I am going to return head here. Before returning head, I have to change the value, head value equal to last, and now I am going to check the corner cases for these values, neighboring nodes. So I'll be taking this as my example 1, 2, 3, 4, and the k value equal to 2. I'm going to run a loop from not equal to none, count is plus, and temp equal to temp dot next, and I'm going to get both the values, first value and the last value. If count equal to first num, I'm going to get that first value. First previous value, then count equal to second. So yeah guys, and here we have to assign that if the first value is the last, and also this, I'm going to assign the first value equal to first brief dot next, and the last value equal to last brief dot next, and then first next equal to first dot next, and the last next equal to last dot next. Here I just initialize the value, and then let's move on to the mapping. Fine. So I have to change the solution must be 1, 3, 2 and 4. My expected solution is here, and we have to just swap these two values. So this is the first previous dot next equal to 3. We are going to do this first previous dot next equal to 3. Let's do it. So first previous dot next equal to last value, and the last we'll be getting the last value here, and then we have to map the last values dot next equal to first value, I mean 2. Last value dot next equal to first value. So we'll be getting here, and the first value of next equal to last value next. First dot next equal to last next. That's it. So I'm going to return it here. So after it we'll be getting 4, and then we are going to check the final keys. Let me explain here. So I'm taking k equal to the same 2, and I'm going to take multiple inputs 5. So the answer is 1, 4, 3, 2, 5. This is what the answer. So let's do it. The previous of the first value. First previous dot next equal to second last value. And then here we'll be getting that 1, 4, and the next of the last value. First dot next equal to the next of the first value. Next here. So we'll be getting 3, and it is the previous value of the second value. So last previous dot next equal to first value. So and we will be getting this, the 2 value here, and the next of the first value is next of the second value. First dot next equal to next of the second value, and last next. Here we have to return it. Yeah, let me run, guys. Yeah, and then I found other issues here, so I didn't swap it properly. Yeah, guys, let's try to run it. Yes guys, it's successful, and thanks for watching. Please do subscribe to the Advent YouTube channel. and please don't hesitate to comment if you had any suggestions. And it's one of the complex problem. Please watch this video another time to get clarified. And if you had any suggestions, please don't hesitate to comment us, guys. Thank you, guys. Bye bye.